Okay, welcome to this little tutorial on empirical formulas. Remember, empirical formulas are the lowest whole number ratio of formulas. So if we have H2O2, that's hydrogen peroxide, the empirical formula for that would be HO. Again, the lowest whole number ratio, whatever you can divide those into. Okay. Now, there's this song, you can sing it, you can put it to a fancy tune if you want, but you take the mass over the formula weight, that's the way you get the mole, then divide the largest by the smallest, press the little buttons as you go, multiply it, multiply it, multiply it, till it's whole. If you really want to sing that, if not, I'm okay with that. Okay, so empirical formulas are basically the reverse of what we do with percent composition. Remember, in percent compositions, sorry, I tried to do something there with a different mouse, but it did not work. Let me get to where I want to be. So, remember with percent compositions, we are finding out how much of, so let's say just for simplicity's sake, H2O, what percent of that is hydrogen, what percent of that is oxygen. So for this, you would take, for percent composition, you take each individual molar amount. So for hydrogen, we have two of those, so we'll just say that's 2 moles. And you divide that by the total weight, so that would be 18. Because 16 plus that. Okay, so 2 divided by 18 then would be about 9. Let me check here real fast and I will tell you. Okay, so then we're looking at that's about 11%. So for our hydrogen here would then be hydrogen equals 11%, okay? Now, so we have to take percent compositions, we can find the empirical formula. We're going to look here at an artificial sweetener of saccharin. Okay, it's a wonderful thing. It makes these little delicacies over here. Okay, first off, it gives us the percent composition is 49.9% carbon, 2.75% hydrogen, and 26.20% oxygen with 17%. I think that's sulfur, and 7.65% nitrogen. Now, with these percents, we always will assume that it is a 100 gram sample. That makes it easier for us to convert to what we need to. Oh, sorry, I pushed the wrong button, okay? So, see here how we start with percent. That's 40 right here. We have 45.9%. We're going to say that that is then equal to 49.90 grams. And this one was 2.75%. If you look back here, see 2.75%. Now we're saying that is grams. Okay, so we take each percent and we change it to a gram. Okay, and again, that's all is assuming 100 grams. Crazy. No, I don't want to change the color screen. Sorry, anyone who watches this on YouTube. Okay, now we have to convert each gram to a mole by using our molar mass. Okay, so we start here with the 49.90 grams of carbon. The molar mass of carbon is that. We change it so our grams are sliced out. That leaves us with moles. That equals 3.201 moles of carbon. And we're going to do the same thing now for hydrogen. Again, make sure our units cancel, make units, we are left with moles. And that would equal 2.728 moles of hydrogen. And we carry on. So we have to convert grams to moles so we can compare all of those. Okay, and so on, so on, and so on. This is a great example. You probably want to write down this example. Your first step is, let me write this right here. Change to grams. Then convert to moles. Okay, so that's our first two steps. Change grams, convert to moles. Okay, then we divide each of the moles by the smallest amount of moles. So here we look. We had 0.548. Sorry, I will get better with the marker. That's our smallest mole. So we're going to divide each of those, that same number, into each one. Okay, ideally we want it to come out to be a whole number like this. 5.0 is wonderful. 5.3.0. Excuse me. But since they all do not come out to be, we have this dang little decimal up here. This is when part of the song is multiply it until it's whole. Okay, so we could multiply that by 2. Equals 11. So we have to do with this one, you have to multiply it by 2. Equals 10. Multiply that one by 2 equals 6. So if you multiply one, you have to multiply them all. Okay, so now that tells us what is our lowest whole number ratio for carbon, hydrogen, oxygen, sulfur, and nitrogen. Then you take each of those and you make that into the subscripts. So it becomes C11, H10, O6, S2, N2. Keep in mind this is the lowest whole number ratio. We would, I don't know why I keep doing that, but that is kind of annoying, for Pete's sake. I'm almost done with my first video. Hallelujah. Sorry I didn't have any intro music. I'm still working on that. Okay, so right here, where'd that marker go? Okay. Wow. Okay, so this is our empirical formula. Now, a molecular formula may be in a different amounts, but the ratio will always be like an 11 to 10. So we would have like 22 to 20 to 12 to 4 and 4. Okay, so the ratio amount has to stay the same, but for different molecular formulas, you could have different amounts of carbons, hydrogen, oxygen, sulfur, and nitrogen. Okay, empirical formulas, not tremendously hard. If you just remember, change the grams, change the moles, divide by the smallest one. If we look back here at our song, hopefully now it makes sense. Oh, it went too far. The mass for the formula weight. Okay, we did that to change the moles. That's how you get the mole. Then divide the largest by the smallest number of mole. Press the little buttons as you go. Multiply it till it's whole. Fantastic song. Okay, that takes care of the empirical formula. You may have a quiz on this tomorrow. And I think that's coming out against my sign to stop. Okay, peace out.